Hey guys, and welcome back to another video. Today we are going to be preparing some nickel 2 oxide from a nickel source. First, we must obtain some nickel metal. Unfortunately, it is illegal to melt, dissolve, or destroy coins in Canada. On a completely unrelated topic, Canadian nickels made before 1982 are pure nickel metal, and nickels produced after 1982 are an alloy of copper and nickel or nickel-plated steel. This is observed when weighing the coins, as 20 nickels made after 1982 weighs 80 grams, whereas 20 nickels made before 1982 weigh 90 grams. This is because nickel is denser than steel. For U.S. citizens, the U.S. nickel is 75% copper and 25% nickel. So back to the project. Some nickel metal must be obtained. This can be found in some nickel-based batteries, or if you have some old blank nickel discs laying around like I do, you can use those. First, we can add the nickel disc to a large Erlenmeyer flask. I have 90 grams of nickel discs here. Then we can cover the discs with some concentrated hydrochloric acid. This can be found as muriatic acid at various hardware stores. It is best to add the hydrochloric acid in small quantities throughout the dissolution, as some hydrogen chloride will be lost from the solution from off-gassing during the heating. Nickel metal reacts rather slowly with hydrochloric acid, so it is necessary to gently heat the solution to aid the dissolution. This reaction should be done outside or in a fume hood, as it produces hydrogen gas, which is explosive. If bubbling ceases but nickel metal still remains, additional hydrochloric acid must be added. Despite heating, it still took over a day for everything to fully react, but once it was done, a nice dark green solution of nickel 2 chloride was obtained. As a side note, nickel 2 salts are carcinogenic, so it is important to avoid direct contact with the solution, and gloves must be worn. Next, a very concentrated solution of sodium hydroxide is prepared. An excess is necessary to fully react with the nickel 2 chloride and destroy unreacted hydrochloric acid. With strong stirring, the sodium hydroxide solution can be added slowly to the nickel 2 chloride solution to prepare nickel 2 hydroxide. After the addition, the solution can be vacuum filtered. The goopy nickel 2 hydroxide paste was scraped from the vacuum filter and transferred to a 1-liter beaker. The beaker was then heated on a hot plate to decompose the nickel 2 hydroxide to nickel 2 oxide. This decomposition occurs around 230 degrees Celsius. Unfortunately, the material in the beaker turned black as green nickel 2 oxide oxidized to black nickel 3 oxide around 400 degrees Celsius. To convert the nickel 3 oxide back to nickel 2 oxide, it could be heated over 600 degrees Celsius and then left to cool without exposure to air. After cooling down, the nickel 2 oxide was a greenish-brown color, so some of the powder was still likely nickel 3 oxide. However, it is better than it was before. In the future, the dehydration of nickel 2 hydroxide should be performed either in an apparatus with an inert atmosphere or in an oven while ensuring the temperature stays well below 400 degrees Celsius. This nickel oxide still contains some sodium chloride from the neutralization of the hydrochloric acid, so to clean it up, about 200 milliliters of water is added to the mixture and it's stirred. Next, the nickel oxide is vacuum filtered and rinsed twice with 100 milliliters of distilled water. The nickel oxide is much easier to filter and rinse compared to the hydroxide, so it is easier to remove excess sodium chloride now. After vacuum filtering, the powder was left to dry completely, and in total 118 grams of nickel 2 oxide was obtained. This corresponds to a 103% yield based on the starting nickel discs. Although the powder looks dark in this lighting, it is actually a greenish-brown color. The high yield is likely due to nickel 3 oxide contamination. However, there should not be much yield loss throughout the entire process, so this suggests that most of the compound is nickel 2 oxide. Nickel 2 oxide is a useful catalyst in hydrogenation reactions, and it is also used in some batteries and as a starting point to make other nickel compounds. We will specifically be using it to hopefully catalyze the decomposition of sodium pyrosulfate to sulfur trioxide in a future project. Anyhow, I hope you guys enjoyed, and I'll see you in a future video. Remember that it is illegal to destroy currency. Okay, bye.